When performing load calculations for a commercial building, understanding how to accurately determine general receptacle loads is essential. Typically, the calculation involves comparing the building's area multiplied by a standard volt-amps per square foot value, often 1 volt-amp per square foot, against the total volt-amps derived from the number of 5-15 or 5-20 receptacles, each assumed to draw 180 volt-amps. Several scenarios can impact this calculation. Firstly, if the actual load connected to a receptacle is known, then that value should be used instead of the default 180 volt-amps. This provides a more precise representation of the electrical demand. Secondly, consider a situation where a standard receptacle is replaced with a dedicated 20-amp receptacle, but the actual load remains unknown. In such cases, the load calculation should reflect the full capacity of the dedicated circuit, which is 120 volts multiplied by 20 amps, equaling 2400 volt-amps. Thirdly, if a customer specifies a requirement for a certain number of dedicated receptacles to power specific devices, such as computers rated at a known wattage, the actual wattage of the device should be used for the load calculation. The circuit's ampacity, such as 20 amps, is used to determine the overcurrent protection and wire size, but the device's actual wattage determines the load. Now, let's address Mike Holt's example, which calculates the total volt-amps by summing the maximum volt-ampere rating of each receptacle circuit. This method assumes that each receptacle is loaded to its maximum capacity, which may not be realistic in practice. When using this approach, it's possible to arrive at an inflated load calculation. If it is known that the devices will not be operating at their maximum load simultaneously, applying a demand factor might be appropriate to reflect real-world usage patterns and prevent oversizing the electrical system. Oversizing can lead to increased initial costs and reduced efficiency. When determining receptacle loads in commercial buildings, it is important to consider several factors. Firstly, the NEC provides minimum requirements for general lighting and receptacle circuits in commercial buildings, typically based on the building's square footage. For example, the NEC may require a minimum of 1 volt-amp per square foot for general lighting and receptacle circuits in office buildings. Secondly, the NEC allows for demand factors to be applied to receptacle loads based on the type of occupancy and the expected usage patterns. Demand factors recognize that not all receptacles will be used simultaneously or at their maximum capacity. Thirdly, specific equipment loads such as HVAC systems, elevators, and large appliances should be calculated separately and added to the general receptacle load. These loads typically have higher demand factors than general receptacle loads. Fourthly, it is important to consider any future expansion or changes in the building's occupancy when determining receptacle loads. Adding extra capacity to the electrical system can help avoid costly upgrades later on. Fifthly, local building codes and regulations may have additional requirements for receptacle loads in commercial buildings. It is important to consult with local authorities to ensure compliance. The NEC provides guidelines for calculating receptacle loads in commercial buildings. It is important to exercise engineering judgment and consider the specific characteristics of the building and its occupants. Overestimating receptacle loads can lead to oversizing the electrical system, while underestimating receptacle loads can result in inadequate power supply. It's also important to consider the impact of energy efficiency measures on receptacle loads. Energy-efficient lighting and appliances can significantly reduce the overall electrical demand of the building. The building's electrical system should be designed to accommodate these energy-saving measures. Moreover, the location of receptacles should be carefully planned to ensure that they are conveniently located and accessible to building occupants. The NEC provides guidelines for the spacing and placement of receptacles in different types of occupancies. The selection of receptacles should also be considered. Receptacles are available in various types, including standard duplex receptacles, ground fault circuit interrupter receptacles, and arc fault circuit interrupter receptacles. The appropriate type of receptacle should be selected based on the location and the intended use. For example, ground fault circuit interrupter receptacles are required in wet locations such as bathrooms and kitchens. Arc fault circuit interrupter receptacles are required in bedrooms and other areas where there is a risk of electrical fires. The installation of receptacles should be performed by qualified electricians in accordance with the NEC and local building codes. Proper wiring techniques and grounding procedures are essential to ensure the safety and reliability of the electrical system. Additionally, the receptacles should be regularly inspected and tested to ensure that they are functioning properly. Any damaged or malfunctioning receptacle should be replaced immediately. The use of extension cords should be minimized, as they can create a fire hazard. If extension cords are necessary, they should be heavy-duty and properly grounded. Power strips should be used with caution, as they can overload the electrical circuit. It's important to consider the total load connected to the power strip and ensure that it does not exceed the circuit's capacity. Furthermore, surge protection devices should be installed to protect sensitive electronic equipment from voltage spikes. Surge protection devices can help prevent damage to computers, televisions, and other electronic devices. The building's electrical system should be regularly inspected and maintained to ensure that it is operating safely and efficiently. A qualified electrician should perform the inspections and maintenance in accordance with the NEC and local building codes. The electrical system should be properly grounded to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. The grounding system should be regularly inspected and tested to ensure that it is functioning properly. The building's electrical panel should be properly labeled to identify the circuits and their corresponding loads. This will help facilitate troubleshooting and maintenance. The electrical panel should be easily accessible and kept clear of obstructions. The building's electrical system should be designed to accommodate the needs of all building occupants. This includes providing adequate power for lighting, appliances, and equipment. The electrical system should also be designed to be flexible and adaptable to future changes in the building's occupancy or use. In addition to the above considerations, it's important to factor in the potential impact of future technologies on receptacle loads. For instance, the increasing use of electric vehicles may require additional charging stations in commercial buildings. The electrical system should be designed to accommodate these future demands. Smart building technologies can also play a role in optimizing receptacle loads. Smart lighting systems can automatically adjust lighting levels based on occupancy and daylight availability, reducing energy consumption. Smart power strips can automatically turn off devices that are not in use, further reducing energy consumption. The integration of renewable energy sources, such as solar panels, can also help reduce the reliance on the grid and lower overall electrical costs. The electrical system should be designed to accommodate these renewable energy sources. Finally, it's crucial to document all load calculations and electrical system designs for future reference. This documentation will be helpful for troubleshooting, maintenance, and future upgrades. The documentation should include detailed information about the building's electrical system, including the size and location of all receptacles, circuits, and equipment. By carefully considering all of these factors, it is possible to accurately determine receptacle loads in commercial buildings and design an electrical system that is safe, reliable, and efficient. Always remember that electrical work can be dangerous, and it is important to consult with qualified professionals to ensure safety and compliance with all applicable codes and regulations. When dealing with any kind of electrical installation, firstly, adhere strictly to the National Electrical Code and local regulations. Secondly, ensure all work is performed by licensed electricians for safety and compliance. Thirdly, regularly inspect electrical systems for wear and tear and address issues promptly. Fourthly, always disconnect power before working on electrical components to prevent shocks. Fifthly, use appropriate personal protective equipment, including insulated gloves and eyewear. Sixthly, properly label circuits and electrical panels for easy identification. Seventhly, never overload circuits with excessive appliances or equipment. Eighthly, install ground fault circuit interrupters in wet areas to prevent electric shock. Ninthly, use arc fault circuit interrupters in bedrooms and living areas to reduce fire risk. 10thly, implement surge protection to safeguard electronics from voltage spikes. To further elaborate on commercial building load calculations and receptacle considerations, it's beneficial to explore specific scenarios and advanced techniques. Firstly, consider a large open office space with a high density of workstations. In this case, calculating receptacle loads based solely on the minimum volt-ampere per square foot requirement may significantly underestimate the actual load. Instead, a detailed assessment of the equipment used at each workstation, including computers, monitors, printers, and other peripherals, should be conducted. Secondly, in retail spaces, receptacle loads can vary considerably depending on the type of merchandise being sold and the layout of the store. For example, a clothing store may have lower receptacle loads compared to an electronics store, which requires numerous outlets for product displays and demonstrations. Thirdly, in healthcare facilities, receptacle loads are critical for powering medical equipment and ensuring patient safety. The NEC has specific requirements for essential electrical systems in healthcare facilities, which must be designed to provide uninterrupted power to critical equipment during power outages. Fourthly, when calculating receptacle loads for restaurants, it's important to consider the power requirements of kitchen equipment, such as ovens, refrigerators, and dishwashers. These appliances typically have high power demands and may require dedicated circuits. Fifthly, for data centers, receptacle loads are extremely high due to the large number of servers and networking equipment. The electrical system must be designed to provide reliable and redundant power to ensure continuous operation. Sixthly, in industrial facilities, receptacle loads can vary widely depending on the type of manufacturing processes being performed. Some industries may require heavy-duty receptacles and dedicated circuits for specialized equipment. Seventhly, when calculating receptacle loads for mixed-use buildings, it's important to consider the different occupancy types and their respective power requirements. For example, a building with both office and residential spaces may have different receptacle load requirements for each occupancy type. Eighthly, it's also important to consider the impact of energy storage systems, such as batteries, on receptacle loads. Energy storage systems can help reduce peak demand and improve the overall efficiency of the electrical system. Ninthly, advanced metering infrastructure can provide valuable data on receptacle usage patterns, which can be used to optimize load calculations and identify areas for energy savings. Tenthly, building information modeling can be used to create detailed models of the electrical system, including receptacle locations and load calculations. This can help improve the accuracy of load calculations and facilitate coordination between different trades. To further refine the process, it is useful to consider the application of diversity factors. Diversity factors allow for the reduction of the total calculated load based on the understanding that not all connected loads will operate at their maximum demand simultaneously. These factors are often determined based on historical data, industry standards, or engineering judgment. Moreover, when planning for future expansion or changes in occupancy, allocating additional capacity for receptacle loads is prudent. This foresight can prevent costly electrical upgrades down the line. Incorporating power monitoring systems can offer real-time insights into energy consumption and load patterns, allowing for informed adjustments to the electrical system. In situations where there is a mix of known and unknown loads, prioritize the known loads and use appropriate assumptions for the unknown loads based on the building's function and potential equipment usage. Where applicable, consider the use of smart receptacles that can provide data on energy consumption and allow for remote control of devices. When working with large receptacle circuits, use voltage drop calculations to ensure that the voltage at the furthest receptacle is within acceptable limits. Remember, the goal is to strike a balance between providing adequate power for all connected loads and avoiding oversizing the electrical system. Collaboration with electrical engineers, contractors, and building owners is essential to ensure accurate load calculations in a well-designed electrical system.